Hello.
Good morning, sir.
Good morning. Do you have any issues, questions? Someone asked for average marks, right? So you send it.
Yes, sir. Got it.
Yeah. And the slides of Amit that already module. So I hope you received it. So actually I'm teaching very slow this time. Although I'm not in rush, but we have probably another how many class left. So today I'll finish Hammett, okay? And then next week, we have another 3 class probably, 3 or maybe 4 on Saturday. Yeah, this is the slowest teaching. Okay, so let's start. Any questions? If it is no, then okay. So let's start. Okay. So last time, I think because of the internet problem, some one of you told to repeat the last 1 or 2 slides. So it's okay. So we will discuss about the scale. Can you see my slide or not? Full screen? Yes. Yeah. Okay. So let's discuss from this slide. Okay. So we discussed about the scale of Hammett row values. Okay. So Hammett row values, this is a scale from 0 to -6 and +6. Left hand side is -6 and this is +6. Okay, on the right hand side. So this scale will give some hint. So rho is the experimental value that is coming from the slope, right? Of the Hammett equation, second part. So rho value and also its sign will give an hint that whether in a rate determining step, whether any charge is generating or not in the rate determining step compared to ground state, always, right? The experiment will tell what is the changes in the transition state in the rate determining step from the ground state for anything, right? Entropy of activation or anything. Okay, this is a change. So rho value will tell that is what about the changes of charges of the molecule involving in the rate determining step. Okay, so here as I told that this is quite specific. So rho value you have to use a substrate where you have at least one phenyl groups are here. And these phenyl groups have a substituents. So you will vary from electron donating to electron withdrawing groups. Okay, at least 3 or 4 substituents. Okay, at least this to make a plot, because in the plot, when you are making a plot, you need minimum 3 data point, right? So you should have minimum 3 different substituents. Suppose methyl, methoxy, and chlorine. Okay, or maybe or maybe 4 substituents. Okay, methoxy. Hydrogen, X is hydrogen, then suppose cyano and nitro. So depending on the availability of the substrate, okay, substituted substrate. So the rho value, first of all, if it will tell it's a plus or minus, and it will give what kind of charge is creating in the transition state or rate determining state. Okay, also the value will tell that where is the positions. So if the value is 0, not 0, it's in between the plus and minus, that will tell. Okay, so if plus charge is there, rho is a plus value, means negative charge is creating in the transition state. Okay, compared to ground state. Or I will discuss in the next slide with the examples. Maybe ground state is positively charged and excited state, the positive charge is decreasing. Okay, the value. Or maybe ground state is positively charged and excited state in the rate determining step is neutral. So what is the changes? Effectively, you are decreasing the positive charge, right? So on those cases, the rho value will be plus, means you are creating a negative charge in the excited state compared to the ground state. We will discuss more. So if it is the negative value, then means positive charge is creating in the rate determining step. Very simple. If it is positive, that means the opposite negative charge is creating in the rate determining step. Clear? So this a plus or minus sign will tell what type of charge is creating. Okay, compared to ground state. So this is the opposite. Negative, positive, positive, negative. Okay, is it clear? Okay, and the values. So if it is the +1 to -1, okay, so that indicates that wherever the charge it is creating in the atom, okay, so this is far away from the aromatic ring, because your base is this aromatic ring, right? How much charge is creating, how much charge is creating in the aromatic ring having the substituents. So whatever the charge is creating, that is too far away from the aromatic ring, that bears the substituents X. Okay, so you'll get an hint that what is going on, where the plus charge is occurring, okay, in that molecule in the rate determining step. If it is -2 to -4, then it indicates that definitely this is the higher value, rho value. Okay, so you can see here that indicates that the charge is creating close to the aromatic ring having substituents. If it is negatively charged, means positive charge is creating close to the aromatic ring. So there will be an electron flow out of the ring. Okay. And if it is +2 to +4, that indicates that negative charge is indicating. So there will be a electron flow into the transition state, into. Okay. So the aromatic ring will be more negatively electron rich if it is a positively charged, because negative charge is creating close to the aromatic ring. If it is plus 5 to plus 6 or minus 5 to minus 6, that indicates that wherever the plus charge it is creating, that plus charge is creating either on the aromatic ring, like here, or in the conjugations, or suppose benzylic positions is conjugated. Okay, so if it is plus charge, means negative charge is creating in the rate determining step, either on the aromatic ring, okay, or on the benzylic positions or any other positions which is conjugated with the aromatic ring having X. Okay, so that the influence of X will be very high. The value will be 5 or 6. Depending on the charge, it can be plus or minus. Is it clear or not? Any questions? So look, if the rho value is -2 and another is -2.2, okay, it is not much significance, okay. But if it is the -1 and another one is -6, or -2 to minus and another one reactions, you are getting rho value -6, that will give a hint. If two reaction, one is giving -2, another is giving the rho value is -2.5, those are not much meaningful, okay. But if there is any significant gap, suppose -2, one reactions, another one is -6, then definitely it will give a huge hint what is going on, or how much, where is the charge is creating, how much charge is creating in the rate determining step. It will help you to understand. Okay. So this is a simple example. So I told you, if it is the benzoic acid, AR means pH with substituents. And if it is an equilibrium, or suppose it's a deprotonations of benzoic acid, then what will be the value of rho? 1. I discussed before, right? Am I correct? Okay. If it is the ArCH2COOH, the third one, to ArCH2COO minus. So now you can see the negative charge is far from the aromatic ring. Okay, so this negative charge is creating, isn't it? Yes or no? Negative charge is creating. So what will be the rho value? Plus. How it will compare? You can see this minus 0.5.6. That indicates that it is less significant than the benzoic acid I discussed in the last class. If it is less than 1. Plus charge means negative charge is creating in the rate determining step. So if you go left hand side to right hand side, negative charge is creating, isn't it? In the aromatic ring molecule. Okay. Now you can see this is the plus charge. Now whatever the rho value, you should expect this is less than 1, because the COO minus, it is far from the aromatic ring. Right? So it is less sensitive. Rho value will be the less sensitive, sensitivity constant compared to the benzoic acid. If the COO minus is even further from the aromatic ring, okay, you can see this is the plus charge, but rho value is further decreased 0.24. Okay. This is the reprotonation of phenol, substituted phenol. You can see here O minus is conjugated with the AR, right? Phenol is conjugated. Am I correct? Okay. So rho value yield the positive, okay, and it is significantly higher compared to non-conjugated system. All right. Okay, the next one is quite interesting. Okay, here you may questions that why it is the 2, not more than high. Okay, so this one is quite interesting. You can see this ammonium is an anilinium ion. Okay, ArNH3 plus. So in the equilibrium reactions on right hand side, this is ArNH2 plus H plus. So in the aromatic ring, from left hand to right hand side, positive charge is creating or negative charge is creating? What will happen?
Sir, could you repeat your question, please?
This reaction, anilinium ion, On the right hand side, it is aniline, right? You can see
Yes.
here to here. From left hand side to right hand side, aromatic ring is getting more electron rich or more electron deficient?
The electron rich.
Electron rich. The positive charge is decreasing.
Exactly. It is now neutral, right? So electron charge is positive charge is decreasing, means compared to ground state, negative charge is creating. Am I correct?
Yes, sir.
Compared to ground state. Yeah, negative charge. So what will be the rho? Plus or minus?
Positive.
Plus.
Positive, because you are creating the negative charge compared to ground state. Although there is no negative charge, but compared to ground state or opposite way, you are decreasing the positive charge. So it will be positive. Okay, right? So this makes sense. So you can see this is the plus charge. This is conjugated. When it is little far from the next one, so it will be positive. But see the value. It is much lower compared to plus 3.19. Does it make sense? Questions? Okay. So you can see here also, suppose this reaction, this one, ArCMe2Cl reacting with water to give the ArCMe2OH, right? So what will be the possible mechanism? What might be?
SN1.
SN1 type of reaction, something like this. This is the reactions, right? You can see Ar, CH3, Cl, and your rate determining step. Rate determining step is the creation of positive charge, that is benzylic positions on the benzylic position. So what will be the rho value? Okay, first is sign, plus or negative, minus. Rho value?
Negative.
Rho value will be the negative. You can see here negative value. And how much you should expect the rho value? Rho value should be very high, right? Close to 5 or maybe 6. Normally 6 comes when it is positive charge on the aromatic ring. Okay, and if it is the conjugated, then you may consider close to 5. Okay, actual calculation is minus 4.48. I told you the values, it is little bit of fluctuations. You may ask, oh, sir, you told your scale is, if it is conjugated, it should be minus 5, but this is close to minus 5. This is minus 4.5. Okay, so a little bit of fluctuations, those are meaningless. Okay, those are not meaningful. But the high value of rho indicates that positive charge is creating in the excited state or rate determining state, and not only for that, the positive charge is creating close to the ring. Probably it is in the conjugated. Does it make sense?
Yes, sir.
Yes. Okay. So look, I'm going to give you the same example again. We discuss about this equation, right? This. What about this? Benzyl chloride reacts with water to gives the benzyl alcohol. Okay, so what might be the possible mechanism? So when benzyl chloride, like this is hydrogen, what?
SN2.
You don't know what is the mechanism. My point is you don't know what is. You should tell, sir, I don't know the mechanism. I can tell you, but I don't know. Suppose it's not your fault. You are not doing any experiment. Okay. Suppose you don't know the chemistry much, or you forgot what is SN1, SN2. Okay. So you should tell me, I don't know. Right. Oh, don't write in exam copy, right? That I don't know. Then I'm sorry. Okay. In class, it is okay. That is my duty to teach you, but not in exam. Right. So exam don't write I don't know, but class you should tell I know. So now I will help you to understand you what will be the possible mechanism. So I am giving you the rho value here, or I'm giving you the rho value here. What is the rho value? What is the rho value? Minus 1.31. First thing is minus means you have generating a positive charge in the aromatic ring. All right. But interestingly, the value is minus 1.31. It is close to 1. Okay. It is unlike from the SN1, so it cannot be SN1 type of reaction. It cannot be something like this. Because if it is SN1 type of reactions, okay, in the rate determining state, positive charge is creating in the benzylic position, then you should expect it is close to -5. Am I correct? So that is telling that it is not SN1. There is something else. So you ruled out. I told you, right, in the quiz questions, what is the definition of mechanism, right? Which rules out all other possible mechanisms. So it is ruling out SN1. It cannot be. So find out what are the other options are there. There might be thousands of options, but one of the common option is might be SN2. Now you will look at also, is it supporting SN2? You decide, write down in a piece of paper and you find out whether it is supporting or not. Is it supporting? Okay, we will see. This you may draw a SN2 mechanism transition state. So what is the transition state? The carbon center is 5-member, right?
Yes.
Yes. The carbon center is 5-member. All right, it already drawn. So what is happening here? What is happening here? This is the water and this is the Cl. So what will happen? It will have a negative. This is cleaving, right? This is cleaving. Okay. So it is cleaving. So this is a neutral molecule, but in transition state, there will be a slightly charged distributions. Okay. So this will be the negative and it will be little bit of positive. Do you understand? Because it's breaking the bond, CCl bond, and CO bond is forming. So there will be a partial charge distributions. Okay. So when the oxygen is giving, it will also give you the little bit of del positive, because oxygen lone pair is you just try to understand. Okay, my drawing is it is attacking. So lone pair will is water molecule. Lone pair will attack to the carbon. So there will be a partial positive charge on the oxygen. There will be a partial positive charge on the carbon and partial negative charge on the chlorine. So the del value is negative, but small amount of negative, right? Because whatever the plus charge is creating, that is small amount. It is not a carbocation. This is a del plus. That's why rho value is slightly negative, -1.3.
Sir,
Yeah.
why is there a partial positive charge on oxygen? I mean, it has electrons, right? It has not completely given its electron to the carbon.
Yeah, but it's water, right? It's neutral.
Okay.
It's neutral, right? And what is happening? It is donating the electron, right, to the carbon center.
All right, I got it. Thank you.
Yeah, yeah. Okay. Same thing like here also. If O minus is there, then it will negative charge will also dispersed. We discussed in SN2, right? So you are decreasing the negative charge.
Sir, had it been OH minus, then oxygen would have partial negative, right? Since it is not neutral.
Yeah.
If you add
water is neutral, right?
All right.
Water is neutral. Okay, clear. You can see here that how rho value is really helpful to understand the mechanism of a organic reaction. I told in the last class that here Reid law cannot distinguish this pathway, right? I told yesterday. Reid law cannot tell, entropy of activation cannot tell, but it will be very much helpful about the value of rho. All right, it will really helpful. Okay, this is the power of Hammett plot. All right, so little more example. All right, so you read this slide. Do you have any questions? The first one is rho equal to 1. We discussed in the last slide, right? Same thing. So what about here? Rho value is 0.5 because the whatever the negative charge will create, that is far from the aromatic ring, right? Phenol we discussed, isn't it? We discussed this one also. Yes or no? Last slide. Yeah, we discussed here, right? Ammonium, everything.
Yes.
Yeah, these we also discussed last. SN2 type of reactions, and someone is asking that if it is the O negative, same thing. So this SN2 reactions is not water, this is a phenolic. Okay, so you can see here O minus is reacting here, I minus is creating here. So minus and partial positive charge is creating on the carbon center. That's why this is negative, but this is the 1 value. Okay, so it is quite far from the aromatic ring, and whatever the charge is generating, that is very small partial charge. That's why rho is small amount. Okay, but these reactions we discussed also in the previous slide, that if it is SN2 type of reaction, you will get a very high rho value. So this is a summary slide with a little bit of different drawing. Any questions? I will wait for 1 minute. Any questions? If it is not clear, I will repeat again. Questions? No?
No, sir.
All right. If you don't have questions or not many questions, then there are two. There I will think there are two things. Okay. Either what I am teaching, you can understand everything. So that is my credit, right? And what I am telling, you can understand everything. Or opposite way, you didn't understand anything. That is my discredit. Okay. So I don't know it is my credit or discredit. That you decide.
Understood, sir.
You understood? Okay. All right. I believe you. Hey, people. How many attendance today? 26. A little better than yesterday. Okay. Okay. So I'm not going to discuss all about the all examples. Okay. You just practice in home. Okay. So you can see that what is the value of this. Okay. For this equation is the very common reactions of the Elide reactions. Okay. This one, second one, third one, you draw, you practice. Okay, and see that how rho value is, what is the rho value, and why this is high, why it is low. Okay, this is also high, and why it is plus minus, and also you practice with the mechanism. I'm not going to discuss all. Okay, if you have any questions, you can ask me. So just I want to discuss the last one, because the last equations we discussed multiple times before during the red law, right? That is the nitration of benzene, and this is an industrial reaction. Okay, industrial reaction. So nitration of benzene, right? I told you, right? So benzene is coming from petroleum. Treat with nitric acid in presence of sulfuric acid, you will get nitrobenzene. Nitrobenzene has various applications. One of the major application is aniline. Okay, aniline has a lot of applications in pharmaceutical industry, many chemicals. Okay, so this is aniline. Okay, it is produced in ton scale. So what is the mechanism I told, right? We discussed during the red law, number one. We also discussed during the I think isotope effect. I think during the isotope effect, right? So you can see here during the isotope effect, I think we discussed, right, that first step, the electrophilic substitutions is the determining step, that you know that. Okay, or if you don't know, I told you, that is also fine. So isotope effect will tell you that this is the first step is the determining step, or this step is the determining step, right? So we discussed, you may remember that what is the KH by KD here? Is the primary kinetic isotope effect example or secondary?
So no kinetic isotopic effect.
No kinetic isotope effect. Okay. So that indicates that the second step is not the rate determining step. Am I correct? Because CH or CD bond is breaking in the second step. So we propose that kinetic isotope effect is telling probably first step. Okay. Look, negative experiment you cannot tell. So KH by KD is 1. Suppose KH by KD is 1. There is no isotope effect. That indicates that CH or CD bond is not being broken, or maybe there is no much effect. So at least the second step is not the rate determining step. But that cannot tell whether the first step is rate determining step. They may suggest maybe because it's a negative experiment. Am I correct? So if isotope, there is no isotope effect, it can tell that second step is not the rate determining step. But a kinetic isotope effect cannot tell you that whether the first step is rate determining step or not. Right? Okay. It cannot tell. It may suggest, but it cannot tell really. Okay. It may not suggest because you have other steps are there. How you can tell? Okay, you have two steps, then kinetic isotope may tell that okay, maybe second is not there. Second step is not rate determining step, so probably the first one. If it is the two option, because you have two options, one is deleted, then you have only one options. But if it is the three option, three step synthesis, then it cannot tell. So rho value is indicating that it is minus 6.4. What does it mean? The first step is it is positive charge is creating, and the value 6.4, it is telling a strong positive charge is creating on the aromatic ring. I told you, right? If it is very high value, minus 6, minus 7, that is creating on the aromatic ring. Okay, or at least it is also, it may be also the benzylic position, but regardless, it is telling either on the aromatic ring or benzylic position, but it's the benzene, so there is no benzylic position. Okay, so whatever the positive charge will create, strong positive charge that will create on the aromatic ring. So it is strongly suggesting that first step is the rate determining step. Am I correct? Does it make sense? Yes or no? Hello guys.
Yes, sir.
Yeah, isn't it interesting, right? See? So it is minus 6.5 is interesting. So it is telling that okay, the first step is the rate determining step. Okay, because positive charge is creating and also in the aromatic ring. So interesting, so helpful to establish the mechanism. Okay. All right, this is more example. I am not going to discuss, or maybe yeah. Okay, you just look at this examples. If you have any questions, you just let me know. Just look at for 2 minutes. There are 3 examples. 1, 2, practice. Okay, questions may come from these examples also. This is the value, so what kind of experiment you can do, or maybe this is the mechanism, so what experiment you will do and what outcome you can expect to distinguish this mechanism versus this mechanism. Okay, you can also see here hydrolysis of ethyl acetate, alkyne hydrolysis, rho value is plus 0.26, but acid hydrolysis is 0.1. What does it mean? What does it mean? Why? We should practice. Okay, question may come, exactly same question. All right. All right, so look at for 2 minutes. Any questions you can tell. I'm not going to discuss. Then I think I will discuss little one more thing. Then I will finish the Hammett plot.
Sir?
Yeah.
So in the second example, it says rho value is negative, right? Although very close to zero, but it is negative, which means that a positive charge must be generated somewhere.
Yeah, that is integrating.
But in this Diels-Alder reaction, there's a cyclic transition state. There is no positive charge device.
Well, but your experiment is correct. So, okay, first of all, I will tell that you can see the value. This is close to zero.
Yes, sir.
Right. So,
Very small. Positive
very
charge.
small is negligible effect. So that is indicating that in transition state, there is, you may tell that there is no charge separations or charge creation is happening. Okay, because this is almost neutral. Starting material is not neutral, and also,
Yes.
yeah, that's maybe a little bit of positive charge is happening. It may happen. Why not? Depending on the R effect or minus I effect or something. Okay, but it's almost neutral. So there is not any significant charge separation is happening in the red revealing step. And it's correct, right? Cyclic transition state. Why you will see a charge separation there? So this is correct, right?
Yes, sir.
Yeah. Anything else? If it is not, let's go. Let's move on. All right, last. So Hammett plot, whenever you will plot Hammett, many times you will see there is the slope. I told you that Hammett can be negative slope or it can be positive slope, right? Okay, so x-axis is sigma and y-axis is log sigma x divided by log sigma h, right? Log kx by kh, not sigma h, right? For any unknown reaction. But many times you may see that Hammett plot becomes nonlinear, something like this. So you can see this is an equation that been okay, acyl chloride PHCOCl. It is a very common reaction. Okay, and room temperature is very active also. Okay, if you just add water, okay, it will convert to acetic acid. Ar is the substituted pH. So if it is pH, then acyl chloride, right, to give the acetic acid CH3COCH, CH3COOH. Okay, so if you just change the substituents here, x is Ar means pH x, then you will see that this is the sigma value is negative and this is positive value, right? You can see that when, so negative, since this is electron donating groups, right? You can see when the groups are electron donating beyond PHCl, then your this is rho value is negative. That means, so you can see the value minus 4.4. Okay, so that means positive charge is creating in the transition state, right? And after a certain sigma value, it is moving upward. It is giving the positive rho value. Okay, and you can see the inflection point. It is the PCl. Okay, 4 positions means para Cl. So this is the negative. So it is the electron withdrawing groups. So you can see that when electron withdrawing groups are there, and electron withdrawing power is greater than Cl, then rho value becomes positive. That means negative charge is creating. So this indicates that whatever the rate determining step it is there, it is changing. Rate determining step or mechanism is changing depending on the substituents on the aromatic ring. Okay, this is quite interesting. Okay. So what is the mechanism and how it is affecting? So your mechanism is, there are two kinds of mechanism is possible. One is mechanism 1. Okay, so what will be the mechanism? One mechanism will be that simple that you know from your high school, that acyl chloride water is attacking, right? Water is attacking in the rate determining step. So what will be the red law? Red law will be first order with respect to acyl chloride, first order with respect to the water. Not only for that, what kind of rho value you should get? What What will they get? So here electron donating groups will help you for attack, or electron withdrawing groups will help you to attack the water. Here.
Electron withdrawing.
Withdrawing groups will help for attack, because if you electron withdrawing groups, then you are increasing the electrophilicity of the carbonyl carbon. Am I correct?
Yes, sir.
Yeah. Okay. So this will be the rate determining step when electron withdrawing groups are here. So in this part, mechanism 1 will be prevalent, because electron withdrawing groups will increase the electrophilicity of the carbonyl carbon, and that will help the water to attack. Correct? Okay. I'm erasing everything again. All right. Is it clear? Now what will happen, that if you are using the electron donating groups, will it be favor? No, it may favor, but there is something changes mechanism is happening. So non-linear Hammett plot is changing, that rate determining step is changing, or mechanism is changing on changing the substituents. So what is happening, that when electron donating groups are here, then you are creating a positive charge. So this kind of mechanism cannot happen when rho is negative. It cannot happen, because this is positive charge, and you can see the value minus 4.4 means you are getting a positive charge close to the aromatic ring. So what would be the mechanism? One possible mechanism is something like SN1 type of things. Okay, unimolecular reactions for CCl bond is giving, and an aromatic carbonyl cation is forming, and this is the conjugated. Okay. So on those cases, only if you determine the rate law, it will be only the first order and zero order with respect to water. And it can only happen when electron donating groups are there, because it will stabilize the cation. Does it make sense? Yes or no?
Yes, sir.
So please repeat.
Yes.
I'm repeating again. Is mechanism 1? Okay, I'm repeating again from beginning. So look, nonlinear Hammett plot indicates that definitely there is a change of mechanism. First of all, when electron donating groups are here, you have electron donating groups are here, right? And this side sigma value is positive. This is the electron withdrawing groups are here. Suppose this is the NO2 is here, right? And this is the OMe he is here, this side. So when electron donating groups are here, then it is indicating that, okay, forget about the left hand things. It is indicating that the positive charge is creating in the rate determining step. Am I correct? Not only for that, this value you can see minus 4.4, that is indicating that the positive charge is quite significant and it is close to the aromatic ring. Maybe it is conjugated, minus 4. Okay. But here you can see when electron withdrawing groups are here, it is telling that whatever the rate determining step, there is a change here. Okay, there is a change here. Whatever the electron, whatever the rate determining step is here, negative charge is creating. And not only for that, this value 2.5 indicates that this is whatever the positive charge, this is not conjugated. Not conjugated. Okay, clear? All right, so you can see here.
Sir.
Is it clear or not up to here?
Clear.
Yes. Okay. So there are two kind of mechanisms possible. Okay. So one is the mechanism 1, that is very most common, right? That water will attack to the carbonyl carbon. Okay. Here not much charge is changing, and here what will be the mechanism after that? Negative charge will create or positive charge will create? What will happen? Negative charge or positive charge? Negative charge, right?
Charge.
But simultaneously, you will also have positive charge also here, right? Right. So whatever the charge it is, okay, you can see here it will be in the aromatic ring. So this mechanism 1 will be helpful. It is obvious that when aromatic ring will be electron withdrawing, electron deficient. Am I correct? Because if it is electron deficient, then it will increase the electrophilicity of the carbonyl carbon and it will help to attack the water. Is it clear? Is it clear?
Yes, sir.
So electron, when X is electron withdrawing groups, then it will help the water attack. Okay, here. So this mechanism one is prevalent in the green color. I have it is shown here that when rho is plus 2.5. Okay, all right. But when rho is negative and minus 4.4, when the X is electron donating groups. Okay, so you can see. So and not only for that, it is also indicating that whatever the rate determining step, it will happen in the positive sigma value, means electron withdrawing group, electron donating groups are here. On those cases, the positive charge will be close to the aromatic ring because see the value minus 4.4. Okay, so the second mechanism, when sigma is plus, this is the mechanism. So where for Cl bond is cleaving to give the aromatic carbonyl cation. You can see this cation, this is conjugated, right? This is conjugated in the aromatic ring. Okay. And not only for that, you are creating a strong plus charge. Okay, that's why your rho is minus. So this non-linear Hammett plot is telling that there are two different kind of mechanism or rate determining step is operating. One is here, another one is here. I don't know why today, whenever I'm drawing in mouse, it is giving like this left hand side. Okay, so this is indicating that on changing the X from electron donating groups to electron withdrawing groups, your rate determining step or mechanism is changing. So Hammett plot is helping you to tell that there is a change of mechanism of the same reaction. The reaction is same. At the end, you will get substituted acetic acid. Okay, regardless is a mechanism 1 or mechanism 2. Okay, always your product is same. But what about the mechanism? What is the rate determining step? It is telling that there is a change. The Hammett plot will tell you. Does it make sense?
Yes, sir.
Yes, sir.
If it is not, read it. I will discuss again, or I can discuss now also. We still have some couple of minutes left. So let me clear. This is the last one. Okay. If it's not clear, tell me. This is the last slide. So this is the end. So next week I will teach differently. So now my mechanism part is done. So later I will discuss more examples with acid catalysis, base catalysis, some other catalysis, nucleophilic catalysis. This year Nobel Prize was given in chemistry on nucleophilic catalysis. Okay, so we will discuss about the nucleophilic catalysis, organocatalysis. Okay, we will discuss this year. Nobel Prize was given. Okay, in chemistry. So that we are teaching also. Okay, in every year in CML 103. Okay, on nucleophilic catalysis or organocatalysis. And for every cases, whatever the mechanism it is, we will discuss about these 4 experiments. Red law, isotope effect, activation parameters, and Hammett. All right. So these are the tools to determine the mechanism. Okay, we need to know the science, right? What is going on? All right. So this is my last slide before Diwali. So any questions?
No, sir.
If it's not, then happy Diwali.
Happy Diwali.
Happy Diwali, sir.
Happy Diwali, sir.
All right.
Sir,
Yeah.
by
Tell
when
me.
should we get our marks of pre-major total, like?
Pre-major. Okay, so that we will give it. We will give. Okay, we are now grading. Okay, so quiz we will give it soon for next week. We also don't have time, so next week we will give the quiz marks. Okay,
Sir, please give it before 8 because it's the last date for auditing.
Before 8th will be difficult because there are so
Okay.
many copies. There's
Okay,
one
sir.
copies.
No problem, no problem.
Okay, you got the minor marks or not? Minor?
Yes, sir.
Yeah, quiz is only 20 marks. Okay, because we need some time. Okay, because the thing is that okay, now students are going home. Okay, who will grade? We will also check. We will check, but there is too many copies. 140 copies. It's not like that. Only 30 people are coming. Not 30. We'll be lucky. How many days 30 people joined? I don't know. The maximum is 20, 25. It's not like the 25 copies I can get within 2 days. But 140 copies, it will take time. And now it is mine 1 and 2. So, but next week for sure. So we'll do, today is the 3rd. So by 10th or 11th, we will give it. Okay. But I think your grade or something, whether you will, I think you are, you are talking about add drop, right? So whatever you want to do, I think you should not be dependent on the quiz marks. Okay. And quiz is very easy, right? What is the definition of mechanism? I told you many times, right? And all other questions is a very simple questions. Very simple questions. Okay. Same thing I told you that okay, questions will come like this. And sufficient time. Even Professor Sasandip was telling that we should not give more, it should be done within 30 minutes. It's 20 marks questions. Initially I thought 1 hour, then we decided it is 40 marks. Okay, because Professor Sasandip, it will take 10 minutes. He is supposed to give 10 minutes. Right, it's true and false questions. But we give sufficient time. Okay, I have no problem if you give all 100 marks. I will give you all A. We are a good grader. I always give good grades. Okay, you ask your seniors also. Alright, so but it's up to you. Okay, if you write I don't know, then how can I give you the marks? That is the only things. Okay, so give us 1 week. Okay, I think next Wednesday 10 or 11th we will give you the quiz marks. Okay.
Sir, will
Sir,
the
in minor,
major,
Yeah, what happened?
sir, will the major full syllabus?
Yeah, this is the IIT policy. Well, for mine it is the full syllabus. I think for Sasana is the full syllabus. Yes. All major, every course, it will be full syllabus.
Also, weightage will be 10%, and how will the weightage distributed be?
It is already written in the flyer, right? So
No sir, you आपने जो पढ़ाया और उन्होंने जो पढ़ाया उसका.
No, listen. So my part and Professor Sasandip's part, it will be equal. I think mine is the 40 marks. Professor Sasandip is 40 marks and 10 quiz. That is 100, right? So in the final exam, mine will be the 40 and Professor Sasandip, minor is how much? 20, right? Minor?
30, sir. 30.
30. Minor is 30.
Weightage.
Weightage. Then Professor Sasandip's will be 10 marks. Okay, 10 marks. Mine will be 40. Sir, okay. Yeah, it will be equal. 40, 40, 20. Means 10, 10. Okay. So overall mine will be 50 marks, including quiz, and Professor Sasandip will be 50 marks. Right. Yeah. Because we are teaching equally. Okay. All right. Anything else? If it's not, I will leave and enjoy Diwali, but be safe. All right. So see you on Monday.
Thank you, sir. Happy Diwali.
Happy Diwali. Bye bye.
Yes.
Thank you, sir. Happy Diwali.
Thank you, sir.
Bye bye.
Thank you, sir. Thank you, sir. Same to you.
Thank you. Bye bye.